Okay, today we're going to start with chapter 9, something called pointers. And pointers, we've actually seen just a little bit, but pointers is something that's going to become really important in CPS 162. In fact, we'll actually take part of the time in 162 and come back to chapter 9 and do a little bit of work taking a look at the pointers. But you typed in some code listings, and hopefully we will be able to make the code listings make sense. And let's see what we have to get started. Pointers. Pointers basically, I'm going to be able to create a new variable. And the variable is going to be a pointer variable. And when I create a variable that's a pointer, that means it's going to hold a memory address. And when I create this pointer variable, I need to know what type of data is stored at that memory address, like an int, like a double, and so on. So, we'll use the term I'm pointing to an integer or I'm pointing to a double, different types of things. But a pointer is a variable that I can use to get to an address. Just to remember, the address of something was given by the ampersand, and we saw this when we were passing reference variables in my parameter list. If I wanted a value to change, I could get a value to change. Okay. The address is stored as something that we call hexadecimal. And you had a program, you had a code listing you wrote, and it actually printed out ampersand X. It was in code listing 1. It printed it out, and you saw that you got some bizarre things like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. I think there was actually an X in the address. Okay. This is counting using hexadecimal, where, it's a base, it's base 16, but I run out of my world of numbers. So after 9, instead of 10, it's A. 11 would be B, then it would be C, D, E, F. Now that I've run out of those, I jump to 1, 0, 1, 1, 1, 2, 1, 3, all the way up to 1, F. Then I go to 2, 0. And some of you are taking CPS 230, and you've seen a little bit of work with hexadecimal numbers already, also known as base 16. So when you see an actual address, it kind of almost means nothing 98% of the time to actually look at the address. But when you look at it, you're going to see it in hexadecimal. So if I want to get the address, I have the address operator. It's the ampersand. Okay, so let's talk about a pointer variable. Well, we've already seen some pointer variables. The name of an array is a pointer variable, not with the square brackets, just the name of the array. We've taken a look at reference variables already. Those are the ones where in my parameter list, I have the ampersand. Finally, today we're going to talk about creating our own pointers. And eventually, like I said, in 162, these become huge. All right, so with the array, it's the same as if the name of the array. For example, numbers is a pointer. I have an array called numbers, dotty, dotty, dotty. I passed numbers in my parameter list. I was actually passing an address. Okay, same with the reference variable. Here's an example of the reference variable. When we had a variable like donut, and I did int ampersand donut, I was passing in the address of an integer variable. All right, so that's the past. Now it's time to start talking about creating our own. So the first thing I needed to do is define this variable. And I'm going to define it with int asterisk pointer. Now, this is what I've seen 99.9% of students use, because it helps remind that it's by using that asterisk, and we're going to use it one of 2 different ways. By using the asterisk, it's saying I want to create a variable called PTR that's a pointer to an integer. Now, if I wanted to, I could have written int asterisk space pointer, but that's not really too common. This is the big way we write it. most common way, int space asterisk pointer. So what I'm saying now is I have a variable called pointer that can hold the address of where some integer is stored. Hopefully that doesn't sound like Charlie Brown's teacher right now. Walk, 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 right? Okay. Creating a variable called pointer that's going to store the address of where some integer is stored. All right. One of the things I can do with my pointer is to give it a default value. And different versions of Dev C++ want you to use different things. Null pointer is what probably most of you have. Some of you may have to use null, capital N, capital U, capital L, capital L. A final option would be to use 0, because 0 is false, 0 is null, 0 is the null pointer. It's all that, it all comes back to 0. So depending on which laptop or computer I use, and the version of Dev C++ I have on, there is one that null pointer doesn't work. So I double click and put a 0 in, double click and put a 0 in all of them, so that I know it's safe. So 0 is really safe if we wanted to. Now, code listing 9.1, take a quick look at that. Here's the one where I create a variable called x, and by putting the ampersand in front of it, it's going to allow me to get the address 0x8f05. Another note in here, we have a method called size of. What size variable is this? Well, it's a byte. So you see over here in the output, 4 bytes. Kind of interesting, at least it is to me. Code listing 4.2 was the next one you typed in. And now I'm actually getting into the nitty gritty of, I have x, an integer variable x, give it a value 25. I create a pointer that's going to point to an integer. I come down here and say, hey, PTR is going to be allowed to hold an address. I want it to hold the address of x. So when I come down here, I print pointer, and what should come out is the actual address of x. Again, that's pretty much it for us using addresses, but that's where the address of x comes in. Now, code listing 9.3, and I have it written in my notes, and hopefully you do too. And I'm going to start with the code. X is an integer again. I create a pointer. The pointer gets the address of x. Okay, when I come down here, I am now putting this asterisk in front of the pointer, which says, remember, pointer is the address. The asterisk is going to do something called dereference it, which means go change the value. Change the value at this address. This address is where x is. So this line of code is saying, hey, go change x to 100. And again, you come up here and you start to look at, I have highlighted and underlined in red, when the indirectional operator is placed in front of a pointer variable. So here's my second use of the asterisk. It's called the indirectional operator. Okay, when I put it in here, it's going to dereference it and allow me to give a value. So I'm going to dereference that pointer, which means I'm now able to give it a value. So some quick terminology, right? Dereferencing. I have the indirection operator and dereferencing. So now I have x. Whoops. I have x, and I dereference that address where x is. Notice I get 100. So these two lines are basically interchangeable. X and asterisk x are interchangeable. X is the value of x. X is asterisk pointer is the value at the address stored in pointer, which is x's address. So I get that value. Questions? Here's another example, right? X has a value, ba-da-ba. Pointer gets the address of X. I change it by adding 100. Pointer gets the address of Y. I change it by adding 100. Pointer gets the address of Z. Again, I dereference it, take the value that's there and add 100. So as you can see, I started with the three values, 25, 50, 75. I added 100 to each one of them so that when I displayed them, they had their new values. Good, nice and quiet. So what do we have going on here? I have some notes. The real benefit, you can indirectly access and modify variables being pointed to. Don't really see that yet as a real value, but I got it. The indirectional operator is the asterisk. Again, just mentioned that. It dereferences the pointer so that I can get the value. I know, right? I'm doing a lot of talking. I don't like when I do all the talking. Okay, we just looked at code listings 9.3 and 9.4, and we're ready to start moving on to a little bit more meat with pointers. And what we're going to take a look at is the relationship between a pointer and an array, okay? And the note I mentioned a little while ago is the array name is now the same as the address. It can be used to point to that address. So if I really, really wanted to, I could have a pointer. Say I have array num. And, you know, on and all of my declarations. And it's an array of integers. Okay. And then I go and say int pointer. I know I'm pointing to an integer, right? So I could do this if I wanted to. Pointer gets the value of array num, because array num without the square brackets is an address. Pointer holds an address. What would this give me? What is this?
Like
the
the
same?
first number in the array.
Right.
So like index 0.
Excellent. So asterisk pointer, which is the value at that address, which is really the same as array sub num. So this is something a little new. I've changed the way I talk about it in 121 a little bit, you know, starting to mention that this is something called an address. But now we're here and we're ready to use it. This is an actual address. So they are in fact directly related. And as you can see in my notes, int numbers, if I have an array, asterisk numbers, okay, asterisk numbers is the same as number sub 0. We created a pointer variable and gave it the value of numbers, you know, and we could dereference it that way. Now, how do I move through an array if I'm using addresses? Really important. What you see in this next line are the parentheses. What if I didn't have the parentheses? What would happen? What if I just said asterisk numbers plus 1?
It
What would
would
I
just
get?
into element 0 in the array.
And then do what to it?
Add 1.
Yeah, add the value 1 to it, right? It wouldn't be like you see over here. So if I want to go through, I need to have the parentheses so that I can move, you know, so I can actually move over a subscript at a time. So if this is an array of integers, that plus 1 basically moves me how far?
To element 1.
To element 1, but what's the amount of memory it's moving me over?
4 bytes.
4 bytes, right? It's going to move me over an int, which is actually 4 bytes. So it's funny how this works, but the compiler will know to move over 4 bytes on that. Okay, take
So if it was something like a long int, which is 64 bits,
Yep.
would then move over 8 bytes instead? Or wait, did I do the math in my head right?
Yeah. Yes. Yep. So whatever the size of the data type we have. Now, we didn't talk about structs yet, did we?
No.
No. Okay, so then I don't want to bring up a struct. Anyhow. Okay, so program 9.6, code listing 9.6, you type this in, you have an array called numbers. And you notice what I'm doing here. I'm going through and filling the array using the address and a +1, +2, +3, +0 actually it started because I started 0. So there's a direct relationship there. Hopefully some of you typed in 9.6 and you saw that right away. Code listing 9.7. I have an array called coins. It's an array of doubles. I have a pointer to a double. Okay, double pointer, nice name. It's a good name. Double pointer gets the address of the array. This documentation stuff's really good. Assign the address of coins array to double pointer, which is kind of what I said. All right, so I want to display the contents. Use this, I can use subscripts if I want. Well, let's see what we have here. Here's the array name. Well, actually, it's not. It's my pointer. But remember, double pointer and coins are the exact same. So if I wanted to, I could have coins here or I could have double pointer. Now, like me, a lot of you are still saying, what's the use? Why can't we just use the array name? Well, we need to really learn about how these addresses work for future work. So it seems odd, but it's a building block. Okay. Down here, instead of using the pointer, we actually use the array name. So they're interchangeable, right? Here I use the pointer in place of the array name with subscripts. Down here I use the array name instead of the pointer and did the pluses, like the +1, the +2, and +3. Again, they are in fact interchangeable. And the last code listing I want to talk about is the one you see in front of you, code listing 9.9. I create an array in line 8. I have a pointer that's going to point to an int. I come in and I assign my array name over. Num pointer gets the address, good. And what's going on here? What's going on in line 20 and 21?
It's increasing the value.
No.
Is it like incrementing the address, like moving over the address over one?
Excellent. Yeah, excellent. Line 21, when I do the ++, is moving the address over, it's an int, 4 bytes. So line 21 moves the address over 4 bytes at a time. So the very first time I'm at num pointer, all right? I'm at num pointer, which is the beginning of the array. I dereference it so that I can print out the first value in the array. Then I move over 4 bytes, dereference it and print it out. So the first time it printed out the 5, it moved over 4 bytes, then it's going to print out the 10, then the 15, all the way out. It's going to print out the 40 and then move 4 bytes past the 40. So right now, that's the address that num pointer is holding. Well, when I come to this next loop, very first thing I do is come back 4 bytes so that I can get to dereference the last thing in the array, which was the 40. So now I keep moving to the left 4 bytes at a time so that I can print out 40, 35, 30, 25, 20. It's kind of cool. I think so, in a nerdy way. Most of you are nerdy ways like me. Julie, I see you're in class. Welcome. I don't want to mark you absent. Questions?
Yeah, I have one.
Go ahead.
It's more of a general question than
Sure.
that specific example. So we can't return arrays in C++, right?
So you mean as a return type?
Yeah, could we hypothetically return a pointer that points to where an array is?
Yep. Yep. And again, it's not really common because we might as well just put it in the parameter list and be done with it.
That makes sense.
Yeah. Okay. Well, I wanted you to do 9.4 and I wrote my answers in and I did them in pen. So let me see what we can do here. All right. So X is 50. X is 50. X is 50. Y is 60. Z is, that's not a Z. Z is 70. I have a pointer, points to null. First thing that happens is pointer gets the address of X. And as you can see, as I don't know if you can see it or not. As you can see, I multiply that by 10. So X now gets a value of 500. Pointer gets the address of Y. Goes there, multiplies, dereferences it, multiplies it by 5, 60 times 5, that gives me the 300. Pointer gets the address of Z. I dereference it, multiply it by 2. What was 70 is now 140. I don't know who the genius is that wrote it in pen. I'm going to try to do this, cover it up. A, valid or invalid? Deal or no deal?
Valid?
It is valid, yeah. Because remember, one of the things I could do was int asterisk this I pointer, but I could give it a default address right away. That default address was null. So that means, yeah, I can give it an address right away. And by doing ampersand IVAR using the address operator, I get the address of this IVAR and I can assign it right away. B, int IVAR, da 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 da. Looks like it's a combination of the two lines in A. So I'm going to say it's all good. Well, why is C invalid?
Different values. One's a float, one's an int.
Yeah, yeah. This, yeah, nothing more needs to be said by me. D, well, that's valid because I declare an array of size 50. I declare a pointer, and right away I give it the address of the array by taking the array's name and assigning it to that pointer. Why is E no good?
You declare the IVAR in after you're assigning asterisk IPTR.
Yeah,
It won't-
exactly.
It won't.
It's out of order, right? It's out of order. I needed to move some things around. Okay, good. I want you to go to page 553. And that's 51, 52, 53. And I'm looking at number 2. Number 2 is something called test scores. Write a program that dynamically allocates an array large enough to hold user-defined number of test scores. How many test scores do you want to input?
10.
10. So we are saying there's 10 dynamically allocating it. So we're going to make an array of size 10. Once all the scores are entered, the array should be passed to a function that sorts them in ascending order. Another function should be called that calculates the average score. And then the program should display the sorted list of scores and the average with appropriate headings. Now, what I want you to do is I want you to do this with just arrays first. Okay, just do it with arrays first. I even have in my note, do with arrays first. Once you get it working, then change all of your arrays so that it works with pointers, okay? Don't worry about the input validation part. So even though this says use pointer notation rather than arrays, I want you to get it working with arrays first, because we're still practicing this whole idea of pointers. Get it working with arrays. Once your arrays are done, then do pointers. So I'm thinking in my head that I need a pencil. I need a function. How many functions do I need?
Your function?
I
3.
need, once all the scores are entered, so I need to fill the array. Sound good? Fill the array. And I think this
A
is gonna be,
sort array?
yeah, this is gonna be a void, and I'm gonna have to pass in array num. Once it's filled, then I'm gonna need to sort it. Void sort array. Again, I'm passing in array num. Once it's sorted, I need another function to find the average. So I might do a double here. Because I can't calc av, and I may be passing in the array. If I wanted to pass in the array and make sure it doesn't change, what word could I add in here somewhere to lock it down so I don't screw it up?
Constant.
Constant.
Const, yeah. So somewhere in there, I want to get that word constant. All right. And then once I have that, I need I think a void display. And in my display, it's going to be my array and my my double, which would be my average kind of deal. So I'm thinking that's what I need. And I want to get that working with arrays. And then I'm going to change wherever there's an array in the parameter list or actually in the function itself. I want to switch that over to pointers. Questions? It's going to take a little bit to get back into typing mode, I know.